Thank you so much, sir, for joining us. Regarding the brief introduction, Dr. Shamindra Sanyal has more than 2 decades of experience in corporate and academia. He is presently designated as Associate Professor, Marketing and Member, Globson Research Cell at Globson Business School, Kolkata. He has more than a decade of experience in management training. He also has nearly a decade of experience in sales and marketing, business development, channel management, and team management in the pharmaceutical industry in different positions. Thank you so much, sir, for sharing your valuable time to us. Over to you, sir.
Dr. Sanyal, I am now making you the host.
Thank you very much, Akshita. Sure. Thank you, sir.
You are the host and you can mute everybody. I mean, they're already muted with provision of unmuting.
Yeah.
So you are the host now. You can share the screen now.
Thank you very much. Thank you very much, Professor Shamindra Mohanty. Thank you very much, Akshita. And thank you very much, the participants, for you have kindly joined the session. This is Shamindra Sanyal. Today we are going to discuss about factor analysis in general and exploratory factor analysis in particular. For you know that factor analysis is one of the very, very important multivariate data analysis methodologies, which is very prominent. It is very popular among all the researchers, particularly for this social science and management researchers for their research profile. And of course, this is something, the factor analysis, which is very much helpful in really doing justice to our research work when we are really dealing with an exorbitant number of data, very high volume of data, huge number of variables out there. So factor analysis really helps us in doing the justice, in doing some meaningful job, in doing some meaningful work in terms of handling such a huge quantity of data, such a huge quantity of variables. At times it may be possible that you are not in a position to deal for example, 50 variables, 60 variables, 100 variables. Sometimes the things like, for example, suppose you have 100 variables and you have 5,000 sample size. So things will be very, very difficult to handle. Things, somebody, Shamindra sir, somebody is saying that is able to see me. I mean, is it the same thing to all of you, that everybody is not able to see me? I do not know.
Yes, sir. Yes, sir.
We can see you. We can see you, Dr. Sanyal.
Okay, fine. Thank you very much. Thank you very much. So I don't know whether Dr. Purna, you have any connectivity issues or not that, because otherwise I'm at least Akshita and Professor Mohanty have told that I am visible. Anyway, so factor analysis is, suppose, I was discussing about 100 variables, 5,000 sample size. So there is a huge data, very, very difficult to control, very, very difficult to deal with such a huge quantity of data. So at this point of time, this is something respite for us, that factor analysis is present. So there are two types of factor analysis. One is known as exploratory factor analysis and one is known as confirmatory factor analysis. In today's session, we are only discussing about the exploratory factor analysis. We are not going to discuss confirmatory factor analysis. First of all, confirmatory factor analysis is a very, very vast process and very vast system, and discussing confirmatory factor analysis as well as exploratory factor analysis will take at least 8 to 6 hours of time, which is not possible, which is not feasible as well. So I will discuss, obviously I will give some idea about what is known as confirmatory factor analysis and what is the difference between exploratory factor analysis and confirmatory factor analysis. Obviously I will give you some hint, the difference between these two. We call them EFA, exploratory factor analysis, and CFA, confirmatory factor analysis. But as of today's discussion, I will only keep myself engaged in discussing only EFA, or exploratory factor analysis. It's very, very important for any researcher, any serious researcher who is doing a very serious research and also wishes to publish a good journal or something like that. So I have rather planned my session in two hubs. The first hub is the discussion, the theoretical discussion through the PowerPoint, and I will give you. Okay, Akshita, Arambam Sophia is, she is telling that they can only see Akshita's screen on the main screen.
Okay, sir. In fact, you can share your PPT, then I think that will be okay.
Acha, acha, acha.
Right
Fine.
now, I have not shared anything,
So,
so they are not able to see.
No, no. Okay, fine. So I believe that now it is visible to all of you. Now the question is that we are discussing about this exploratory factor analysis and the confirmatory factor analysis. Though EFA colloquially is not told as EFA, this is all told as factor analysis. And by and large, we generally refer to EFA as only the factor analysis. For confirmatory factor analysis, we use the term called CFA, but we do not generally use the term called EFA. Colloquially, we use the term called factor analysis only. So factor analysis refers to, in the common person discussion, factor analysis refers to as a discussion about EFA or exploratory factor analysis only. Anyway, what I was referring to is that I have planned my whole session into two distinct hubs. The first hub is that, I will discuss about the theoretical aspects of factor analysis by showing some of these PowerPoint presentations. And the second hub has been kept for the hands-on experience with SPSS. I have shared one data set with you. Professor Mohanty is kind enough to have shared that particular data set with all of you. I am also carrying two different sets of data sets as well. I will show you some of the important aspects of factor analysis, some of the important problems, and some of the important confusions that generally arise as a result of the different aspects of factor analysis. So it will, I hope and believe that it will be of your help if I discuss the different data sets, the differences of opinion, and the problems and the confusions that generally arise out of the factor analysis. So without much delay, let me start the factor analysis process. First of all, let me start with the concept, the different concepts of factor analysis. So let us start from the beginning. So factor analysis is a very simple thing. It's a theory-driven statistical data reduction process. And this is one of the very, very prominent multivariate data analysis techniques. Now, the question is that factor analysis is generally used to explain the covariance among the different observed random variable in terms of fewer unobserved random variable. Now, the question is, each and every factor, or we can also call them construct, which is the result of diminishing the number of variables. So the primary objective of factor analysis is to diminish the number of variables, a huge number of variables, and to make some meaningful factors. So those meaningful factors are carrying all the necessities and all the information of all the variables available. Now tell me one thing, in case of factor analysis, we also refer the variables as the item. So variables and items are synonymous, they are same. So I told you earlier that if you have 100 variables, at say for example 5,000 sample size, it will be very, very difficult for you to handle the whole session. Now, if I can diminish, if you can reduce the number of variables to a meaningful number of, say for example, if after the factor analysis, 100 variables have been reduced to say for example 12 factors. So instead of handling 100 variables, it will be easier to handle the 12 factors. But those 12 factors will be very, very meaningful. What is the meaning of meaningful? Because all the 12 factors should contain the 100 variables. Let us take a very simple example. Suppose some people are gathering in a particular open air, say an invitation program. Suddenly the rain starts. Suppose garden umbrellas are set over there. So what will happen? The people will start to run and to get the accommodation under different garden umbrella. Suppose garden umbrella A, there are 5 people. Garden umbrella B, there are 8 people. Garden umbrella C, there are 10 people. They have all got this, a small, in order to save themselves, they have got this respite over there. So factor analysis is more or less the same. A large number of variables are there. We cannot handle the large number of variables. So we want to set the variables under different umbrella. But the basic difference between that umbrella concept and the factor analysis concept is there. In case of umbrella concept, people are running abruptly. I do not know whether I'm going to, umbrella A or umbrella B or umbrella C. But in case of factor analysis, which particular item or which particular variable will go to which factor is absolutely predetermined. the items or the variables are not running properly like the rainy season or taking the shelter under the garden umbrella. So that is the difference. But conceptually, this is more or less the same. We want to accommodate all the people who are, instead of getting themselves absolutely drenched, they want to take the shelter under different garden umbrella. Same is there. I repeat, only difference is that in case of that umbrella concept, there is absolutely abrupt situation. But in case of factor analysis, there must be some random variables, and those variables, they follow a particular pattern. They follow a particular pattern in order to get accommodated or in order to get a shelter inside a different factors. So 100 variables or 100 items can get the shelter under, say, for example, 12 factors. Maybe factor 1 would contain 10 variables, factor 2 contains 7 variables, factor 3 may contain 8 variables or something like that. Ultimately, all the variables will be accommodated under 12 factors. So 100 is a fictitious number, 12 is also a fictitious number. We really do not know that how many factors will be generated as a result of running this SPSS. This is absolutely an oblivious thing. We are not at all aware. Even after this whole process is over, after the whole calculation is over, then only we will come to know that, well, out of, say, for example, 30 variables, how many factors are generated? Out of, say, 15 variables, how many factors are generated? Out of 20 variables, how many factors are generated? That is very, very important. Because even after finishing the whole calculation, if you do not look at the number of factors, if you do not know how to interpret the whole result, that is the major issue. Since you have experience for the last 3 to 4 days to have idea about what is SPSS and how to interpret the result page or the output page of SPSS, so you have certain experiences as to if you do not know, if somebody does not know the theoretical aspect of a particular statistical analysis, it will be very, very difficult for him or her to analyze or to interpret the output page, the result page of this SPSS, this analysis. So looking at that particular fact or looking at that particular, the reality, I have decided the first I will discuss about the theoretical aspects of factor analysis so that you have a clear idea as such, as much as possible from my side, I will try. And before doing this analysis part through SPSS, at least you can understand how to interpret the output page of factor analysis through SPSS. So unobserved random variable mean factor. Now, factor is unobserved because factor is not at all observed. Observed means when we know, we have some idea about the nature and the characteristics of the variables. Observed random variable means we know about the variable. We have some idea. We know the characteristics of those random variables. That's why they are known as the observed random variables. But when the factor is formed, we do not have any idea about the characteristics of the factors. That's why factors are known as the unobserved variables. These factor characteristics can be understood if you go to the confirmatory factor analysis. But that is not within the purview of this particular discussion. So henceforth, we will simply refer to as factors as the unobserved random variables. So it's basically a combination between the random variables and some umbrella or some boxes, or say, for example, some pot. Inside the boxes or inside the pots, we are trying to incorporate different variables or different items. That is the purpose of that. This much is factor analysis as nothing else and nothing more. The simple objective is that we have different boxes, not predetermined boxes. You know the characteristics of the boxes. We need to accommodate. We do not know how many boxes are there, but this much we know that boxes are available with us. We try to accommodate as much or as many variables or as many items possible randomly, and by following certain terms and conditions and rules and regulations, we try to accommodate those items or those variables inside different boxes. And those boxes available with us, but we do not know the number of the boxes. And second is, we have to follow certain very, very strict rules and regulations in accommodating those items or variables inside the boxes. That is what is the basis of your factor analysis. The most important factor of factor analysis is it is an interdependence technique. Because in this particular case, variables are not classified as either dependent or independent. In case of regression analysis, there is a set of independent, there is a there is a set of independent variable. There is a dependent variable. In case of simple regression, one independent variable, one dependent variable. Multiple regression, one dependent variable, more than one independent variables. So in all those cases, in case of your ANOVA, there is an independent variable, there is a dependent variable. But the beauty of factor analysis is that there is no, dependent or independent variable as such. So this particular technique is known as interdependence technique. So all the variables are dependent within themselves. There is no such dependent or independent variable. So they are all characteristically, they are all same. So the whole set of interdependent relationships among the variable is examined in order to define a set of common dimensions called factors. As I told you earlier, all are same, all variables are same. There is no dependence, there is no independence. So our responsibility is to establish a relationship of interdependence between them, and as far as possible by following the typical terms and conditions in order to try to accommodate them into different boxes, unobserved boxes, and those unobserved boxes are known as the factors. So the second point is there is no dependent variable, there is no independent variable. So these are a set of interdependent relationships. Third, very important perspective is in case of factor analysis, string data is not allowed. Well, I will show you one example by incorporating a string data, that how this SPSS is rejecting the string data. So string data is not allowed. Qualitative data or non-metric data is not allowed. What is allowed? Continuous data to be collected by interval scale is allowed. I believe that you know, all of you are aware that what is known as nominal scale, ordinal scale, interval scale, and ratio scale. So obviously this is a parametric test. Any multivariate data analysis test is a parametric test. So obviously continuous data will be counted, taken by interval scale in this particular application. I have deliberately given a note of interrogation in point number 2, no demographic data. This is a big question around it. One school of thought believes that you can give the demographic data. My experience was, I have been successful in incorporating demographic data in factor analysis. How can you include demographic data? Even you can include demographic data by following interval scale. Suppose, for example, monthly household income. We have given 5 different layers of monthly household income. So 1, 2, 3, 4, 5, giving the interval scale. So you can give this, demographic data. But the problem lies with when you are giving this gender. Gender can be 1 or 0. But if you put 1 or 0, that is going to be a complicated situation. But if you put, say, for example, male as 2 or female as 1, or female as 2 or male as 1, it can give you a good result putting together. So one school of thought says that, and some of the textbooks also say that the demographic data is not applicable. But I request you can try with the demographic data. You can see whether it is giving you a result, a good result, or not so acceptable result. So there is a separate issue. There is a point of debate. There is a point of discussion. Because of the paucity of time, we cannot discuss the details about the realistic approaches of demographic data. But definitely factor analysis, or for example, SPSS in particular, does not allow the string data or qualitative data, non-metric data. It only allows the continuous data or metric variable to be collected by the interval scale. So this is the very, very primary premise or fundamental premise of factor analysis. Some basic assumptions. Variables must be interrelated. As I told you earlier, we call them interdependent variables because there is no separate independent variable. There is no separate dependent variable. So all the variables are interrelated and they are known as interdependent variables. Sample must be homogeneous. If you collect a heterogeneous sample, it may create problem because heterogeneous sample may produce, if your data is not a scaled data, heterogeneous sample may produce outliers. So that is a big problem. You have to remove the outliers and all these things are there. Then you have to go for this factor analysis. But if you use the scale data, say 5-point Likert scale, 7-point Likert scale, or 9-point Likert scale, then homogeneity is a big question. Of course, there is no possible interference of the heterogeneous data. You can use the scale data in case of you have found out the heterogeneous data put it together. As I told you earlier, continuous data to be collected by the interval scale is. One more thing is important. What should be the ideal sample size for a factor analysis? there are different notations. I mean, in terms of this multivariate data analysis, different multivariate data analysis are there. There are different opinions, there are different research papers, there are different data in terms of the ideal or exact sample size of any multivariate data analysis. The question is that some of the pundits, they say that the ideal sample size for factor analysis should be 50 and above. But there is also a big question out there. I will tell you why there is a big question out here, because when we are going to discuss about principal component analysis and of course the common factor analysis, then we will see that principal component analysis and common factor analysis, they will behave in a similar way if the sample size is greater than 30. That means even the sample size is less than 50, that is acceptable. Your sample size must be more than 30. But one set of schools, one school of thought says that sample size must be 50 and above. Another school of thought says that sample size should be ideally 200. 200 sample size is very, very effective for doing any this multivariate data analysis. One school of thought says that your number of items multiplied by 10. So if you have 15, for example, if you have 15 variables or 15 items, the ideal situation will be 15 multiplied by 10, that is 150. One school of thought says that no, it should be item multiplied by 20. So if your item size is 15, if your variable number of variables is 15, it should be 15 multiplied by 20. So there are different, opinions, different school of thoughts. So ideally, we always think that there is a thumb rule that fine, 200 sample size is quite fine. Even you can also go for maybe 300 or something like that. The question is, there is no higher level, or there is no higher range, or there is no, what should I say, limit or the sky of the sample size in case of your multivariate data analysis. The question is that this is applicable for regression analysis because it all depends on the estimation technique which is being used against each and every multivariate data analysis. The question is that where we are using, say, for example, multiple regression, or in, say, for example, case of discriminant analysis, certain things are there where the sample size creates a problem. But when we are using, for example, maximum likelihood estimation or this kind of techniques, in that particular case, really there is no problem with the sample size. You can accommodate as many sample size as possible. So there are different opinions, there are different debates. So ideally, you should consider from 200 to 300, any sample size you can use, and even you can use 50 sample size. Fourth one, models are usually based on linear relationship. Yes, factor analysis is linear, but nowadays, nonlinear factor analysis is also being cultured by the different researchers. So nonlinear factor analysis is getting prominence day by day. But still, we are very much dependent because each and every relationship cannot be linear relationship. The relationships may be non-linear relationships. The question remains is that in order to satisfy the non-linear relationship, linear factor analysis will not do the justice. For that particular case, non-linear factor analysis should be taken into account. But the thing is that this is not the exact time or exact situation to discuss about the non-linear factor analysis. So we will only discuss about the factor, factor analysis, or to some extent your linear factor analysis. One important terminology, let me tell you one thing. For non-metric data, I told that you have to use the metric data. For non-metric data, there is a concept called Boolean factor analysis, or incorporating Boolean algebra. So there is a more complicated issue. We are not going to discuss about the Boolean factor analysis or Boolean algebra. So we are going to discuss within this short span of time only linearity, only metric data, and only this kind of continuous data collected by the interval scale. So taking all the essential parameters into account, we are considering our factor analysis is a linear factor analysis. Our factor analysis does not incorporate any string data, or say, for example, only non-metric data. Our factor analysis only includes the metric data, and that to the continuous data. Metric variables. Multivariate normality not required. This is one of the very, very important aspects of factor analysis, that you do not need to require the multivariate normality. Because if you collect, say, because in case of our management studies, or to some extent the social science studies, mainly we take the collect data by this Likert scale, 5 point or 7 point or 9 point Likert scale. The problem is that for a short limited Likert scale, 5 point, 7 point, or even 9 point, you cannot get the normality. Forget about the multivariate normality. You cannot get even the simple normality. If you expand the number of, the limits of the Likert scale, maybe 11, maybe 13, maybe 15, then you may achieve this kind of normality to some extent. But whatever Likert scale we generally used, 5 point or 7 point, to some extent 9 point, this type of small Likert scale can never achieve the multivariate normality. So this is one of the very, very advantageous situation for us, that in case of exploratory factor analysis, multivariate normality is not required. In case of confirmatory factor analysis, again, multivariate normality not required, because confirmatory factor analysis is governed by maximum likelihood estimation technique. Maximum likelihood estimation technique is such an estimation technique where really normality of the data set is not always required. So the two angles is a very advantageous position. So these are more or less the basic assumption of our exploratory factor analysis. Let us discuss some of the concepts. What are the factors? I told you earlier, factors are the hypothetical boxes and absolutely some unobserved variables. So factors are always the linear composite. Please take a note that we are not discussing non-linear factor analysis. We are discussing factor analysis, linear. So factor is a linear composite. It's basically the process of turning the multiple measures or multiple items in one construct. Construct means, once again, construct and factor are just equivalent. Construct is an unobserved variable. Factor is also an unobserved variable. So the nickname of factor, you can say, is construct. So factor is always a linear composite. It's basically generated by the process of turning the multiple measures into one particular construct. Then a very, very important phenomenon is there called factor loadings. What is a factor loadings? Correlation of a factor with an items. What is that? The relationship between, is very simple thing, whether variable 1, V1, we did go to factor 1 or factor 2. Suppose there are 3 factors. Now we have, say, for example, 10, 12 variables, V1 to V12. Now V1 will go to which particular factor, F1, F2, or F3? How can you determine? The determining factor is the factor loading. Suppose, for example, V1 is going to F2, because the factor loading between the factor that F2 and V1 is the maximum. Factor loading is nothing but the correlation coefficient between the factor and the item or the variable. I repeat, factor loading is nothing but the correlation coefficient between the factor and the item or the variable. If the factor loadings are higher, definitely, suppose for example, we will see that for a particular calculation, even one particular factor can accommodate more than one variables. Now, obviously, I will calculate or I will determine that particular factor will accommodate which particular variable. Say variable 13 or variable 10. Variable 13 and 10 both are going to factor 2. So what will happen? So definitely I will calculate, I will consider the factor loading. If the factor loading between factor 2 and variable 13 is higher than the factor loading between factor 2 and variable 10, obviously variable 13 will be accommodated to factor 2. As usual, the normal correlation coefficient measurement. So factor loading is as good as the correlation coefficient measurement. It's basically a correlation of a factor with an items. Items with the higher loadings are the distinguishing features of a factor. Obviously, with the higher loadings, those items will be going to a particular factor where the higher factor loadings are there. So loading is nothing but is a correlation coefficient between the relationship between a factor and a variable or an item. Third is known as communality. Communality is basically denoted by H square. So as I told earlier, it's something like a variance. So when you are determining the variance, there must be some metric structures out there. So you have to consider the metric structures, you have to determine the variance, you have to go for calculation of the relationship between the factor and an item out there. So variance in a given item accounted for by all the factors, represented as a sum of squared factor loadings in a row from the factor analysis result. So factor loadings are generally represented by lambda. Suppose, for example, there are 12 factors, so 12 factor loadings are there, lambda 1, lambda 2, up to lambda 4, 12. So H square is basically summation of lambda 1 square plus lambda 2 square plus lambda 3 square plus up to lambda 12 square. That means H square is basically a summation I is equal to 1 to 12 in our case, lambda I square. So communality is basically variance in a given item accounted for by all the factors. Is basically sum of squared factor loadings in a row from the factor analysis results. So when the row is concerned, we are determining communality. But when the columns are concerned, we are determining eigenvalue, the fourth one. What is the role of eigenvalue? What is the role of community? We are not discussing about the communality mathematical form in details or eigenvalue in mathematical representation in details. But when we will do the hands-on experience of SPSS, I mean factor analysis over SPSS, I will discuss with you and where the communality stands and where the eigenvalue stands and what are their roles in terms of factor analysis. But this much please try to understand. When we are discussing about the rows of a particular matrix, that is going to the communality part, and communality is equal to summation of I is equal to 1 to n lambda n square. That means starting from 1 up to nth lambda or nth factor loadings, sum of the squares of it. And the same thing is applicable when you are considering this, I mean the column settings in terms of the each and every matrix. That is known as the eigenvalue. I will definitely discuss what is the role of communality and eigenvalue when I will go for the hands-on experience. This is a picture of a factor analysis. Suppose purchase intention is my factor. So under this purchase intention, 5 items are there. Y1, Y2, Y3, Y4, and Y5. And you know that for any this kind of variables, there is always a random errors associated with it. This is very, very important. Please remember that there is no separate dependent variable. There is no separate independent variable. But whatever be the variable, nature of the variable is, there is always a random error associated with each and every variable or each and every item. So this is a factor. Factors are always represented by an oval shape or this circular type of structure out there. And this is, please remember that the circular structure also represents unobserved variable. Technically, theoretically, unobserved variables or structure or constructs or factors are denoted as oval shape or the circular shape. And theoretically and structurally, all the observed variables are denoted by this kind of a quadrilateral. So please remember that for any unobserved variable, do not mark it as a quadrilateral. Quadrilateral is always indicated for the observed variable or observed items. In our case, our variables are items. When these items are accommodated into the particular factor, that becomes unobserved. And this unobserved has become observed when we transfer from exploratory factor analysis to confirmatory factor analysis. But so long this particular unobserved factor is going to be observed, we will make it as the circular shape or the oval shape. So this is more or less the structural picture of a factor analysis. Now let me discuss some more important.
But I had a doubt.
Yes, please.
Sir, can you please give a specific example of observed and unobserved? I couldn't get that point exactly of how to.
Ma'am, definitely. Ma'am, let me take the example of purchase intention. Fine. Now, purchase intention means next stage is, say, purchase, for example. Suppose we are going to purchase a luxury product. Everyone under the sky has the intention to purchase luxury items. But most of us do not have the affordability to purchase luxury item. But yes, my purchase intention is to purchase a luxury item. But ma'am, I do not know. I am not sure whether I am going to purchase a luxury product or not. That's why this purchase intention, it still remain absolutely very mysterious in nature, whether it will really materialize or it will not materialize. So that's why this concept is called unobserved. We do not know the characteristics. We do not know the features of each and every factor. But this much we know. Just for example, Y1, Y2, Y3, Y4, and Y5, these 5 variables have been accommodated into this particular factor. But we do not know the characteristics or the nature of the particular factor. Even exploratory factor analysis will never tell you the nature of the factor. If you want to know the nature of the factor, you have to go to the confirmatory factor analysis. Okay. Thank you.
Sir, suppose we have selected this 5, Y1, Y2, Y3, Y4. From that, can we differ? Suppose if I take 2 observed and 3 unobserved, can we choose like that, or all have to be observed or all have to be unobserved?
No, ma'am. No, ma'am. In terms of choosing the factor, we do not have any role. Like we cannot choose our boss, we cannot choose our factors. Are you getting my point? So factors are generated automatically. But you can choose the variables, because variables are the questionnaires. The questionnaires we have found based on the Likert scale, those are the variables. Fine. So these are absolutely observed. You know the characteristics, you know the features of the variables, but you do not know the features of the factors. That's why unobserved.
Thank you, sir.
Testing the theory. What is the objective? First objective is to test the theory. Second objective is to understand the structure underlying a set of measures. And third objective is scale development. Let me tell you, those who are serious researchers, let me tell you a small concept. You know, we know that we define different scales. So for example, while doing a particular, research paper, and in setting up our questionnaire, we take the help of different empirical scales. Those scales are already published in different journals. So what happens actually, suppose for example, let me take you my example as such. Just 1 year back, we are doing a particular research work and we got a scale of 137 variables. Is it possible to work with 137 variables? So we have to diminish the number of variables. So first we have tried to diminish the number of variables. Then we have done the exploratory factor analysis. From 137 variables, it has come down to another 8 or 9 type of factors. So if you can meaningfully, let me tell you once again, meaningfully, if we can reduce 30 variables to 3 or 4 factors meaningfully, when all the characteristics of the 30 variables can be accommodated into 3 or 4 factors, what is the problem? Even let me tell you one more thing. Even after doing all the factor analysis, those factors, unobserved factors, can also be used as a dependent variable or independent variable in a multiple regression analysis. I repeat, after doing the factor analysis, when you have recovered all the factors, 5 or 6 or 7, whatever number of factors, those factors can also be used as a dependent or the independent variables in case of multiple regression analysis. This is one of the major advantages of factor analysis. That instead of, 30 variables, you can use 5 or 6 factors as a prerequisite of the multiple regression analysis. This is the beauty of the factor analysis. First, understand. Another question is that, yes, please.
Yes, sir. So I would like to ask you, what is the maximum and the minimum number of factors that we can consider to come up with a very objective kind of a research? Like you say,
Very
3 or 4 factors.
This is only a fictitious number, I'm telling you. Yeah. The question is that generally we cannot set. I discussed to you one particular concept, ma'am, called eigenvalue. The eigenvalue is basically the probability value whose maximum value is always 1. SPSS will by default give you the eigenvalue as 1. Now we have to do all the calculation based on the predetermined eigenvalue as 1. Then SPSS itself can find out the number of factors. So that is, you cannot determine the number of factors. There is another way around. There is another solution. Suppose, for example, madam, you have found out that giving the eigenvalue 1, the system has given you 4 factors, but you require 5 factors. What will you do?
Okay.
You can do.
Okay.
There is a solution of it. I will show you that. How can you, by yourself, can find out the number of factors? Because if you set the eigenvalue as number 1, as 1, then the system will give you the predetermined factors, the number of factors. You do not have any control over it. But if you do not keep the eigenvalue as is equal to number 1, then you can determine the number of factors. I will show you. So the number of factors can be predetermined, or you also can determine the number of factors. Now, the exploratory factor analysis. Let me tell you one thing. There are 2 types of exploratory factor analysis. Let me tell you one more thing. There is one concept known as principal component analysis, and one concept is known as your common factor analysis. The basic objective of principal component analysis is right to accommodate which variable will go to which particular factor. This is the responsibility of principal component analysis. The common factor analysis more or less does the same thing. But principal component analysis is being used by factor analysis for determining the number of variables and the number of corresponding factors. Why? Because principal component analysis only considers the total variance. When we will do all the research work, we'll do the analysis, we'll see that total variance is very, very important in case of your factor analysis. What is total variance? Total variance includes unique variance, total variance includes error variance, and total variance includes shared variance. What is shared variance? Suppose, for example, two Venn diagrams are there. Two Venn diagrams are there, and two Venn diagrams are not adjacent but related with each other. There is some shared area within. So that particular shared area, whatever variance is produced by the shared area is known as a shared variance. So unique variance, error variance, and shared variance all putting together is known as the total variance. Total variance is, as I told you earlier, total variance is very, very important in case of your factor analysis. But common factor analysis, it only exists the common or the shared variance. Shared variance is not only that not important, which is not as good as your total variance. So we are generally considering the principal component analysis, not the common factor analysis, in determining the number of factors and the accommodation of the variables into 2, 3, or 4 different factors. One more thing is there, as I told you earlier, if principal component analysis and the common factor analysis values become more or less similar, if the sample size is going to be more than 30. I repeat, principal component analysis and your common factor analysis, they are going to be similar if the number of sample is more than 30. So if you use the sample size more than 30, then obviously common factor analysis and principal component analysis, they have become synonymous. Since principal component analysis is much more powerful than common factor analysis, in the SPSS when we will do, I will indicate, I will show you, I will explain with you that it is by default it is showing the data analysis to be given by principal component analysis. Why? Because principal component analysis is more powerful than the common factor analysis. Anyway, let me show you some of the important pictures. Note this. I discussed about factor loadings. Factor loadings ranges from -1 to +1. As simple as that. For like any correlation coefficient, it ranges from -1 to +1. Inspection of factor loadings reveals extent to which each of the variables contributes to the meaning of each of the factors. I told you earlier, you can accommodate the variables into factors, but that accommodation must be meaningful in nature. That meaningful accommodation is governed by the factor loadings. I told you earlier, factor loading is the correlation coefficient between the factor and the variable. So the higher correlation coefficient, the particular item or that particular variable will go to that particular factor where the correlation coefficient or loading is higher than the others. High loadings provide meaning and interpretation of the factors. Obviously, which particular variable will go to what particular factor is all determined by factor loading. So this is very, very important in terms of the factor loading calculations. Please remember that factor loading is nothing but the correlation coefficient between a factor and a variable or an item. And loading, like any correlation coefficient, ranges from -1 to +1. +1 is the maximum loading, maximum correlation. -1 is the maximum correlation, but reverse correlation. And 0 is the no correlation. The same thing is applicable as correlation coefficient. Now, I am going to show you two examples. One is known as one common factor model, and the second one is known as two common factor model. Some statistical interpretations are involved over there, but I believe that since you have already crossed so many statistical, applications, you don't create any problem. And if you have a, fundamental idea of, regression analysis, so these models will not cause any problem in terms of your understanding. Suppose we have considered a common factor model, like this, a common factor model. Single factor is there. Suppose 3 variables or 3 items are there. So how can you interpret y1 is equal to lambda1 into f plus a variable? No problem. So you can define y1 as lambda into f1. What is lambda1? Lambda1 is the factor loading or the correlation coefficient. Y1, if there is no your so-called error term, then y1 is equal to lambda1 into f, y2 is equal to lambda2 into f, and y3 is equal to lambda3 into f. But since we have to give some error variances, so definitely E1 plus epsilon 1 plus epsilon 2 plus epsilon 3 will be applicable over here. So the factor f is not observed, as I told you earlier, but y1, y2, and y3, all the items are observed. Epsilon represents variability in the y, not explained by f. As I told you, the error variance cannot be explained by factor. And of course, y is a linear function of f and epsilon. I told you earlier, this is the linear factor analysis that we are discussing. We are not discussing non-linear factor. So y is a linear function of the factor and the error variance. This is the model specification of one common factor model. Suppose we have only 3 variables and one particular factor has been generated. Then we'll discuss about model assumptions. What is the model? Yes, any question from your end?
Sir, can you repeat the question again, please?
This one? This one?
Yes, sir. Yes, sir. Yes, sir.
Yeah, sure. This is, suppose, for example, 3 variables are there, y1, y2, y3, and as a result, we have found out only one factor. Okay, so how can you simply represent the factors? The variable is equal to y is equal to lambda 1 into f, lambda 1, lambda 2, and lambda 3. As I told you earlier, lambda is the sign of factor loading. In correlation coefficient, we generally denote R, Pearson's correlation, Spearman's correlation coefficient, Pearson's correlation coefficient. But yes, this factor loading is denoted by lambda. So lambda 1, lambda 2, lambda 3, something like that. So suppose, for example, for initially, let us take for our convenience, there is no error variance. So definitely y1 is equal to lambda 1 into f, y2 is equal to lambda 2 into f, y3 is equal to lambda 3 into f. Please remember that lambda 1, lambda 2, and lambda 3 may be same, might be different. Lambda 1, 2, and 3 may be same, might be different. Since we cannot avoid this, error variances, so definitely it should be plus epsilon 1, epsilon 2, and epsilon 3. What are the specifications? As I told you earlier, factor is the unobserved, not the observed one. But y1, y2, and y3, I indicated earlier, all the items are observed items, because madam asked me the question, then what is the difference between observed and unobserved? Since we know the characteristics, since we know the features of each and every variable, these variables are items, y1, y2, and y3. That's why they are known as observed, because we know that each and every characteristic of this particular variables, but we do not know anything about the factor. So the factor is unobserved. Epsilon represents variability in the y, definitely, because it is related to y. It is not related to the factor. So the error variance is related to the variable itself, not related to the factor. And y is a linear function of f and epsilon. I told you earlier that this is a linear factor analysis, not the non-linear factor analysis. So this is known as the model specification. Now let me discuss about model assumption. What are the assumptions? Forget about factorial causation. First of all, as I told you earlier, that epsilon is not explained by f. That means f is independent of epsilon. Since epsilon is not explained by f, so f is independent of epsilon. So f is independent of the error variance. Since f is independent, therefore we know that if the two variables are independent with each other, then the covariance is always equal to 0. If the variables are dependent with each other, then there must be some covariance values. Since f is independent of error variance, let me go back. Epsilon represents variability in the y and not explained by f. So f and epsilon both are independent. Therefore, covariance value is equal to 0. And these epsilons are also independent for I not equal to j. Therefore, covariance of epsilons are also equal to 0. So many advantageous factors. Since f and epsilon, they are independent, so their mutual covariance is equal to 0. Since the covariances, error variances are independent, given the fact that I not equal to j, the values are absolutely different, then definitely their covariance is also 0. That means each error variance does not hamper the activities of the other error variance. They are absolutely independent. That is the model assumption for one factor model. Third, interpretation. Given all variables in the standardized form, I told you earlier that data must be homogeneous. When the data is homogeneous, all variables will be in the standardized form. And all variables in the standardized form is easily available from the Likert scale or the scale data, 5 pointers, because all variables are in the standardized form. What will happen? Variance f is equal to variance y is equal to 1. That is very, very important. We are going to consider this as the eigenvalue. So variance of y is equal to variance of f is equal to 1, and this particular value is considered to be the eigenvalue. As I discussed with you earlier, some column and row, all these things are there. So commonality is according to the row, and your so-called eigenvalue is according to the column. So forget about rows and columns. This value, variance of yi is equal to variance of f. The full variance is there, and that particular value is known as the eigenvalue. Factor loading, as I told you earlier, factor loading is a correlation between the variable and the factor. So I should not discuss this because it's described earlier. So I should not unnecessarily make the whole system very bitter. Now, communality. I discussed with you earlier, communality is equal to lambda square. As I told you earlier, it should be, it's my mistake, it should be summation lambda I square, where I is equal to 1 to n. So it's a correlation between y and f whole square. So what is communality? Communality is the percentage variance of y explained by f. Percentage variance of y, that means the item explained by f. Forget the uniqueness part. Forget the factorial determination part. We are not going to discuss uniqueness or degree of factorial determination. Right now, it is not necessary. It will unnecessarily create confusion into your mind. So when variance of y is equal to variance of f, the highest value is equal to 1. That is known as the eigenvalue. Factor loading, you know that lambda is equal to the correlation between the variable and the factor itself. And communality is nothing but the percentage variance of y or the variables explained by f. That how much variance is going on or how much variability is going on inside the variables, that is explained by f. That is known as the communality. So with this model interpretation, this is the only one common factor model. But in practice, you will get several factors. As madam was asking the question, how can you say we are getting 3 factors or 4 factors? In practice, we can get, it all depends on the number of variables or the number of items. You can get 10, 12, 15, 20 variables. If the huge data sets are there, you can determine the number of factors, or you may not determine the number of factors that I will discuss with you while discussing this SPSS technique of discussing all these things. Next one. Now the 2 common factor model. Now we are making the process more complicated. The earlier was very, very easy. Is a single factor or single common factor model. Now the 2 common factor model. 2 common factor model will lead to a very, very important concept in factor analysis called factor rotation. 2 common factor model will lead to a very, very important concept in factor analysis that is known as factor rotation. And without factor rotation, we cannot get a very, very specific or very specified result out there. So factor rotation is very necessary. So factor rotation, the concept will be starting from this particular concept. Look at this. Earlier one was a single one. Model specification single. Now 2 factors are there. So first is model specification. Once again, model specification. Suppose F1 and F2, 2 factors are there. F1, Y1, 2, 3, and F2, Y4, Y5, and Y6. The same thing is there, but only difference is that. See, we do not know, we do not have any idea whether this Y1, Y2, and Y3 is going to F2 or Y4, Y5, or Y6 is going to F2. Now, Y1, Y2, and Y3 can go to F1, can go to F2. Similarly, Y4, Y5, and Y6 can go to F1 and can go to F2. We have to determine that Y1 to 6, where they are exactly going. That is what is known as our main objective of factor analysis. Now, this is, look at this particular headline, 2 common factor model orthogonal. Orthogonal means when these 2 factors are independent with each other, perpendicular with each other. When the 2 factors are independent with each other, it is very, very difficult to determine that which particular variable will go to what factor. I repeat, when the 2 factors or several factors are orthogonal, orthogonality means they are absolutely independent with each other. When they are orthogonal, it is very, very difficult to determine out of the 6 variables, which one is going to F1 and which one is going to F2. That's why this complicated situation is there. I am not going to discuss this complicated situation in details, but this much you can know. They see Y1 is equal to, earlier it was only 1. Lambda 1 F plus epsilon 1. That's all. But in this particular case, since they are orthogonal, lambda 1, 1, F1 plus lambda 2, F, so on and so forth. Since in lambda 1, 1, 2 is there, what is 1, 2? 1, 2 is a Y1. So Y1, it can go to F2, it can go to F1. The corresponding factor loading of F1 to Y1 is lambda 1, 1. And the corresponding factor loading from F2 to Y1 is lambda 1, 2. That means y1 is equal to, it is associated with lambda 1 as well as lambda 1. I'm not going to discuss in details about all the theoretical complications, but this much let me tell you. Now the assumption. The earlier assumption was for the single factor, as assumption was f is independent of this and covariance f and epsilon is equal to 0. Possibly the same thing will happen, but in more complicated form. But f1 and f2 are independent of epsilon. Therefore, covariance f1 Ej is equal to covariance f2 Ej is equal to 0. Earlier it was covariance f and Ej is equal to 0. Right now, since two factors are there, so covariance f1 E and covariance f2 E is equal to 0. And since these, epsilon, so the error variances are independent with each other, therefore, there is no relationship. And orthogonal independent, that means there is no relationship between f1 and f2, they are independent. So covariance f2 and f1 is equal to 0. This is known as orthogonality. Orthogonality makes all the problems because we do not know about, since both are independent, f1 can try to extract as many items as possible. F2 will try to extract as many items as possible. We do not know exactly what will happen afterwards. Interpretation?
Sir, one query.
Yes, please. Yes, please.
Sir, in case of orthogonality, can we say that communality of variables will also be there between factors?
Oh, yes, definitely so. Otherwise, how can you proceed? There must be some commonality. Let me show you. Let me show you the interpretation. Once again, given all the variables in standardized form, variance of y1 is equal to variance of f1 is equal to 1. As I told you earlier, this is known as eigenvalue. So eigenvalue should always be 1. Factor loading, the same thing. Commonality, as sir was asking the question. Once again, the percentage variance of yi explained by f1 and f2. That means y1 is getting attracted by both f1 and f2. So that means commonality is percentage of variance of y1 is explained by f1 and the percentage of variance of y1 is also explained by f2. Because, I repeat, since y1 is getting attracted by both f1 and f2, therefore commonality must be the percentage variance of y1 to be explained by f1 and the percentage of y1 to be explained by f2. The earlier case, the one factor model, it was only. So commonality is there. Without commonality, how can you proceed? It must be some commonality out there. Yeah. Because commonality is a percentage variance.
Yeah. Sir, one doubt.
Yes, sir, please.
Sir, in this two-factor model, whenever we are saying that the same variable y1 is going to f1 as well as f2, we can take the highest factor loading into single and we can consider one factor.
Yes, sir, definitely so. The question is that f1 is attracting y1, f2 is also attracting y1. Now, bechara a y1, where it will go, f1 or f2? It all be determined by the factor loadings. So if y, say lambda 1 is greater than lambda 1 2, then y1 will go to factor 1. If lambda 1 2 is greater than lambda y1 1, then y1 is going to f2. It all depends on, sir, the factor loading. If the factor loading is on a higher side, our bechara y1 is going to that particular factor. If the factor loading is a lower side, y1 will not go to the particular factor. As simple as that. It all depends on correlation coefficient of factor loading. Now, second one. When the factors are not independent, they are oblique. So they are highly correlated with each other. The earlier case was they are independent. They are known as orthogonal. The second case, they are not independent. They are known as the oblique. Now the question is once again, but since all the variables are absolutely standardized, so the eigenvalue is equal to 1. It must be 1, always 1. But the oblique factors, which we saw earlier, that covariance f1 and f2 is equal to 0. Why it is equal to 0? Because they are orthogonal, they are absolutely independent with each other. But in case oblique, since they are not independent with each other, so the covariance is not equal to 0. There must be a specific value of the covariance. And the interpretation of factor loadings, that Factor loading is no longer correlation between Y and F. It is a direct effect of F on Y. So the situation has been changed. That's why in case of oblique rotation, we'll see some different results are obtained. I repeat, in case of orthogonal, different results are obtained. In case of oblique rotation, in case of factor analysis, different results are obtained. What different results? In case of orthogonal rotation, we are going to get a final table for our calculation. But in case of oblique rotation, we are going to get, let me show you, two types of matrix. One is known as pattern matrix, is known as structure matrix. I will discuss with you which is more important in case of pattern matrix and structure matrix. In case of, ladies and gentlemen, I request you to look at point number 5. For orthogonal factors, pattern matrix is equal to structure matrix because in orthogonality, the factors are independent. But in case of oblique, the pattern matrix is not equal to the structure matrix. They are different. Now, which one you are going to accept, pattern matrix or structure matrix? I will discuss with you. Now, let me go back. What is the factor rotation? Factor rotation is something which is very, very interesting. The ultimate objective of factor rotation is to make the whole results very, very specific. Let me show you a simple concept. Suppose this is the axis. So different variables are there. Say 1, 2 is there, 3, something like that. Two factors, one is F1, one is F2. If they rotate the factors, the ultimate objective of rotation, rotating the particular factor is to simply make the variables more accessible to the factors. We can make the different opinions in terms of factor rotations. Maybe, for example, before rotation, variable V1 was getting accommodated to factor F1. Maybe possible that after the rotation, variable V1 is going to be accommodated to, say, for example, factor F2 or factor F3. The objective is very similar, to make the result more specific, to make the result more systematic. That's why the rotation. And since we have two types of factors, one is the orthogonal model and one is the oblique model, there are two types of rotations. One is known as orthogonal rotation and one is known as oblique rotation. But in case of SPSS, you won't find anywhere the terms called orthogonal rotation or oblique rotation. Rather, you will find it something called varimax rotation, promax rotation, oblimin rotation. These particular terminologies you can find out. So some of the rotations are orthogonal rotations and some of the rotations are oblique rotation. I will show you with a single data set the results that is derived out of orthogonal rotation as well as the oblique rotation. In the end, the major steps, first is your data collection and preparation, then choose the number of factors to extract, extracting the initial factors, then rotation to a final solution, then the model diagnosis and refinement, and finally in factor scales to be used in further analysis. Further analysis means even with factor analysis, you can do, as I told you, in multiple regression process and all these things are available over there. So this is in a nutshell, the theoretical aspect is a very, very in a simple form I discussed with you because time. Otherwise, it can be discussed, for hours. If you can give me the permission, if Mahapatra sir, Shamindra sir can give us the permission. Right now, what we will do, first I will show you with my own data set that the different aspects of the factor analysis. Then I will request you to take out your own data, which I shared with you earlier, and then practice as to find out the results of the factor analysis. First, I told you, let me go back. First, I told you, in factor analysis, no string data is applicable. No string or qualitative or non-metric variable is applicable. First, let me show you how to do the factor analysis. Let me show you. And is there any question from this particular theoretical concept or theoretical explanation? Please ask me. Otherwise, I will directly go to the practical part of factor analysis. Any question or any clarification? Please remember two things. One is orthogonality means the factors are independent with each other and the covariance of factor 1 and factor 2 is equal to 0. But in case of oblique type of factors, and they are not independent, there is a correlation between them. In that particular case, they are not independent. So covariance of F1 and F2 not equal to 0. So these are the two important things. And please remember one more important phenomenon is that the concept of eigenvalue. The eigenvalue concept is that variance of y1 is equal to variance of f1 is equal to 1. This is applicable for this oblique rotation, oblique case, or this is also applicable for the orthogonal case. This one is nothing but your so-called eigenvalue. And the second one is communality. Communality is the percentage variance of y explained by f1, f2, and whatever it is. That is the beauty. So let me first show how to go for calculating this one. This is the data set.
Sir.
Sorry?
Sir, one doubt.
Yes, please.
Sir, sometimes in some cases, suppose example is that, sir, in case of emotional intelligence, there is 4 factors we are considering. That is self-emotional appraisal, others emotional appraisal, regulator of emotions, and another factor is that. Whether these factors can be made variables or not, sir?
Factors can be made variable. If you want to apply these factors as the variables in case of multiple regression, you can jolly well do it. So the factors, you have derived the factors out of factor analysis. Now those factors are working as a replacement of your variables. Now instead of using a large number of variables in terms of regression analysis, you can use those factors as an independent variable or dependent variable in terms of using it in multiple regression process. That is allowed, that is feasible. Now, look at this particular
Sir,
chart.
in case,
yes,
sir, in case some of the variables are not rotated for any of the factors, what should we do with those variables?
Sir, we are not rotating the variables. We are rotating the factors so that we can optimally accommodate the variables into a particular factor.
Yeah, I'm sorry. I should use the word loadings. In case there is no loading between a factor and a variable.
There must be some loading, sir. Loading is between -1 to, if the loading is 0, say for example, if the correlation coefficient is 0, maybe possible, we cannot predict it clearly. If the correlation coefficient is 0, may be possible that due to your so-called factor rotation, that particular loading will get some positive value, might be possible, because this is very, very difficult to predict what will exactly happen. But the thing is that even if the correlation coefficient or factor loading is 0, we can get some feasible or the meaningful value of the factor loading if we rotate the factors out there. This is possible. Sometimes it is found that if for example, if the factor loading is minus, it has become plus. So number of times you can find out that before rotation, the value is minus, the factor loading. After rotation, it has become plus. Because you are just shifting. Suppose, for example, you are driving. So when you are going, for example, rightwards, you are just turning your steering on the right hand. When you are going to on the left hand, you are turning your steering on the left hand. The same thing is applicable. You are rotating the steering in order to make the whole system very, very feasible and meaningful to you. The same way you are rotating the particular factors, the same thing like a steering. We are going to make the whole thing very more precise in nature. We are going to establish more precision. So in terms of going to the right hand side, you have to turn your steering on the right hand side. Or in order to go to the left hand side, you have to turn your steering on the left hand side. Similarly, in order to make more precision in terms of our value, for calculating, for determining better factor loadings, we have to rotate the factors, like we rotate the steering. So that's the concept.
So it defines the relationship between more precisely.
Oh yes, absolutely. Because factor loading is all about the relationship between the factor and the variable. So in order to make the relationships more better and more stable, we are making this. I will show you that without this rotating and with rotating, what is it going to happen exactly?
Right, sir. Thank you.
Thank you. Look at this particular chart. So this is the particular data. Cities. So we can really understand that. But the only problem is that this particular data set does not have a 50 sample size. So it may create problem in rotation. So I am going to derive the result not based on the rotation. Just I am going to show you the fundamentals of how to learn how to determine the factor analysis value. First, go to analyze. As I told you, is nothing but the dimension reduction. So you can come to just a minute. Let me check. One question possibly has come. Can you study? you see the data? Okay, let me, just a minute. I'm so sorry, I possibly have made a mistake. Yeah, now possibly you can see the data. Now, is it visible to you?
Yes,
Is
sir.
the data set? Thank you very much. First, thank you very much. Now, go to analyze. So you can see cities, then the car brands are there. Number 1 is Mercedes-Benz Mark. Number 2 is BMW. Number 3 is Jaguar. Number 4 is Porsche. And number 5 is Jeep. So city-wise, what is the acceptance of these 5 types of brands? It was collected. It is a data some 5 or 6 years old. Possibly it was collected just after. So based on the 7-point Likert scale, we collected the data that acceptance of 5 types of luxury brands car in the cities from Delhi up to what is that? Up to the region. First, click on the analyze, because you know that for any SPSS calculation, rather most of the SPSS calculation starts from the analyze. Then go to dimension reduction. Why? Because factor analysis is all about dimension reduction. One is factor analysis, one is correspondence analysis. We are not interested with correspondence analysis. So let us click on factor analysis. Now this dialog box will open before you. Cities, then Mark, BMW, Jaguar, Porsche, Jeep. Let's see whether it allows string data or not. Put all the variables. See, it's very, very staunch. String variables are not allowed in this particular list. So our primary assumption that factor analysis does not allow the string variable is proven by this small test, confirmatory test. Fine, fair enough. Then we have to make it all the factors. Now, look at the right hand side. There are some 5 tabs. First is descriptive statistics. Click on the descriptive statistics. This is the dialog box. Only one is chosen by default. That is the initial solution. But we are more interested in correlation matrix, as I discussed with you. The correlation between means the correlation between the factor loading between the factor and the variable. So correlation matrix, first take the correlation coefficients. Choose this. Then it's very, very important to know for any statistical application, for any statistical significance, significance is very, very important. 5% significance, 95% significance, or 90% significance, or maybe 99% significance. Determinant click. Why determinant? I will discuss. Then KMO and Bartlett's test of sphericity. Click. I will discuss what is all about. So initially it was only this initial solution. Then we clicked in the correlation matrix, coefficient, significance level, then determinant, then KMO and Bartlett's test of sphericity. So these two are very, very important. Continue. Extraction. Extraction, 2-3 things are, look at this. Method is principal components. I told you earlier, there are 2 methodologies of this allowing or accommodating the variables into different factors. One is principal component analysis, one is common factor analysis. Principal component is more powerful than common factor analysis because it takes into account the total variance, whereas the common factor analysis takes into account only the shared variance. But I also told that when the sample size is going to be more than 30, then principal component analysis and common factor analysis, they will behave similarly. But still, since principal component analysis is much more powerful than common factor analysis, by default this is, and some other options are there, which we are not going to discuss about. We are only discussing about this principal component analysis. Now, click on scree plot. What is scree plot? I will discuss. Now, ma'am, I do not know your name, but you ask the question first. Look at this extract. Eigenvalue is always 1 or greater than 1. This is the only option. So you do not have any option to predetermine the number of factors. This is number 1. So the calculation that we are doing as of now, it won't allow you to determine the number of factors. It will generate the number of factors by default by itself. So continue. Third, rotation. As I told you, since the data set is very, very small, we are not going for a rotation. Score. As such, there is nothing. We do not want to save as the variable. Forget about it. Fifth one, option. There is only one option. Look at this. If I click on this particular thing, suppress small coefficients, now the question that if you click on it, it will suppress the smaller coefficient, that means the smaller your so-called factor loadings, less than 0.10. First, I will do the calculation based on this. Then I will do something extra into, I will add more spices, more masala into it. Continue. So in the descriptive statistics, I have chosen all these factors. Then extraction, I have only clicked on the scree plot. By default, this is principal component analysis. Rotation, I have not used the rotation because the sample size is very small. Scores, I'm not interested in the scores. Option, I have not set any option, only suppress the small coefficient, which is absolute value below 0.10. That's all. Now, okay. Is the result visible to all of you? Is the output visible to all of you? Is the output visible to you?
No, sir.
No,
This is
sir. No.
data sheet only.
Only data sheet. Okay, let me check. Let me check. So we have to, once again, the same problem is there. We have to stop sharing this and start sharing. Yeah. I believe this is now visible, isn't it?
Yes, sir.
Hopefully this is, yeah. First, look at the correlation matrix. Definitely all the diagonal elements of the correlation matrix should be 1 because mark is to mark, BMW is to BMW, Jaguar is to Jaguar. So all the factors are 1. All the correlations 1. Now look at the other correlations. Many of the correlations are significantly smaller. Some of the correlations are above 0.5. Like for example, say Porsche is to Jaguar, the value is 0.562. Jeep is to Jaguar, the correlation is 0.538. Jaguar is to Porsche, the value is 0.562. Jaguar is to Jeep, the value is 0.538. That means some important correlations are there. But ladies and gentlemen, you cannot find out any correlation coefficient which is above 0.8. You know that if above 0.8 correlation coefficients are there, that means the data set is suffering from multicollinearity. If the value is more than 0.8, the data set is suffering from multicollinearity. If the data set is suffering from multicollinearity, then definitely factor analysis will help to reduce the multicollinearity. One of the important ways to, for example, reduce the multicollinearity or to, for example, minimize the multicollinearity is to get the particular data set gone through the factor analysis. Factor analysis will reduce, or to some extent will rather minimize the multicollinearity. So if your data set is suffering from multicollinearity, there is no problem. Factor analysis will help you to minimize the multicollinearity. As such, this particular data set does not contain any multicollinearity. If there is any, so there must be some correlation coefficients must be more than 0.8. I told you earlier to click on the determinant. What is the significance of determinant? Look at this. At the end of this particular table, correlation matrix, there is a determinant value is 0.351. What is the significance? If the determinant value is less than 0.00001, if the determinant value is less than 0.40, that means 0.00001, then we should say that the determined items are too unrelated. In this particular case, the determinant is 0.351, which is much, much higher than 0.00001. So I can say that items are highly unrelated. That means the correlations will be very, very low. in that particular case, since this is more than 0.00001, that means correlations are very high, which determines that the data set is feasible to undertake factor analysis. So the determinant value must be greater than 0.00001. This is number one. Number two, KMO and Bartlett's test. The Kaiser, Mayer, and Olkin measure of sampling adequacy. The value we see is 0.631. The value should ideally be more than 0.6. The value should ideally be more than 0.6. In this case, the value is 0.631, which indicates that the sample is adequate to continue with the particular factor analysis. Please remember that the sample size is 34, which is higher than 30. Still, the value is just above 0.6. At any point of time, it can be lower than 0.6. So this particular data set is good, but the data set is not so good or not so robust that we can do the factor analysis. Anyway, then come to communality. Now, what is our understanding about communality? We discussed about communality. Communality is nothing but the percentage variance of the variable explained by the factor. I repeat, the percentage variance of the variable explained by the factors. The question is that if I say, for example, here, first is initial communality should always be 1. Now extraction, that means 70 mark, 0.766. That means for case of mark is a variable. So 76.6% variance of mark is explained by the factor. 76.6% of is explained by the factor. Second was BMW. I am just now not considering BMW. For Jaguar, 73.2% variance of Jaguar is explained by the factor. 73.3% variance of Porsche is explained by the factor. And 71.2% of the variance of Jeep is explained by the factor. The only problem is BMW. In case of BMW, only 39.6% variance of BMW can be explained by the factor. So we can understand that except BMW, all the other variables are very, very strong and very, very communicative and very, very meaningful. BMW variable is not at all meaningful. So at times we may discard the BMW variable because this is of not use of ourselves, because the variance is very, very low. Variance explained is very, very low, only 39.6%. One thing I forgot to mention, please go back to the KM1 Bartlett tests. What is Bartlett's test of sphericity? This is very, very important. The value is chi-square test 31.973. That is not important. Importance is the significance value. The Bartlett's test of sphericity must be significant in nature. Why significant in nature? Because Bartlett's test of sphericity is basically, it shows the matrix must have the sufficient number of correlations. Bartlett's test of sphericity shows that matrix or the covariance matrix must have sufficient number of correlation. Yes, we can see our matrix has got a sufficient number of correlation. Our correlation matrix has got sufficient number of correlation. So that means this satisfies the Bartlett's test of sphericity, and the significance is, please do not consider the chi-square value. Please do not consider the degrees of freedom, but please consider only the significance in case of Bartlett's test of sphericity. This is the most important one. That means your matrix, your correlation matrix contains sufficient number of correlation. KMO test indicates that your data set is sufficient enough to continue with the factor analysis. That means your data set is robust enough to undertake the factor analysis. Bartlett's test of sphericity indicates that your matrix, correlation matrix contains sufficient number of correlation. Communality means the percentage of variance of the particular variable explained by the factor. In this particular case, you have seen all the 4 cars, Mark, Jaguar, Porsche, and Jeep. Their all variances are quite possibly explained by the factor. But unfortunate part is a BMW, only 39.6 and near 40% of the variance is explained by the factor. So this is of no use. Now, the question is, how many factors have been derived? 2 factors have been derived. Look at this particular result. Total variance explained. Initial eigenvalue. Look at this. two factors are there. This is factor 1. Cumulative percentage of variance is 43.257%. And the second factor, see, theoretically there are 5 factors. Component 1, 2, 3, 4, 5. Theoretically there are 5 factors. But the problem is that first factor is taking into account 43.257% of variance. Second person takes into account 23.529% of the percentage of variance. So putting together on right hand side, cumulative is 66.785%. I repeat, the first factor explains 43.257% of the percentage of variance. Second factor can explain 23.529% of the total explain. So putting together the cumulative value is 66.785%. So in 66% variance is always already explained. There is no justification of further considering the other factors. So 3, 4, 5, though they are theoretically they are present, but practically there is no necessity of considering those factors. So in our case, 2 factors have been generated. This is factor 1, cumulative, for example, percentage of variance 43.257, and second was 23.529, cumulative 66.785%. So 2 factors putting together, they can explain 66.78% of percentage variance of all the data. That means up to 67% of the variance of all the data, of all the variables, can be explained by these 2 factors. So there is no justification of unnecessarily taking another factor. Now, come to the scree plot.
Sir,
you can remember that. Yes, please.
Sir, can these 2 factors be more than 2 or not, sir?
Yes, sir. Madam asked the same question. I will show you that we can determine the number of factors by ourselves. Don't worry, sir. I will show you. We can determine the number of factors. I will show you, sir. Scree plot. On the y-axis, eigenvalue is there. You know that eigenvalue should always be 1 or above 1. So this is eigenvalue 1. Now look at the factor that above 1, how many hinges are there? Above 1, how many hinges are there? Hinge number 1 and hinge number 2. That means above eigenvalue, there are 2 factors. Even from the scree plot, we can determine how many factors are there. See, rest of the factors, this, all are below 1. That means these factors are not taken into consideration. The factors of the hinges which are above the eigenvalue 1, those factors are the real factors. Similarly, by our calculation, we have got 2 factors only. So this calculation, total variance explained calculation, and the scree plot calculation, they are matching with each other. Now come to the component matrix. Since I have not rotated, this is the final one. 2 factors are there. Mark, look at this. 2 different types of factor loadings. Factor 1 mark is 0.387. Factor 2 mark is 0.785. So definitely the variable mark will go to factor 2 because the factor loading between mark and component 2 or factor 2 is much more than that of the factor loading between the mark and factor 1. BMW, factor 1 minus 0.330, but factor 2 0.536. So definitely BMW will go to factor 2. Jaguar 0.855, Porsche 0.814, 0.267. So definitely Porsche will go to component of factor 1. Jeep 0.715 minus 0.449. So definitely Jeep will go to component 1. The problem is that if we do not rotate the factors, this type of problem will arise. That one particular variable will try to go to more than one factors, because you know that this is orthogonal in nature. That's why each and every variable will try to go to 2 different factors. We can minimize it, the number of this kind of multiple, we call it cross-loading. We can minimize the cross-loading by the application of the rotation. So I will show you, because this particular data set is not significant enough to show you the rotation. I will show you the rotation. As ma'am requested me, and just right as has requested me, if we can predetermine the number of you can predetermine the number of factors out there. I will show you how can we predetermine the number of factors. Let me go back to the data set. Let me go back to the data set. Now, from this particular output page, does anyone have any question? I will definitely discuss once again. Don't worry about it. I will discuss. But right now, any question or any clarification? If not, then I will go back to the data set again, and I will discuss about that whether we can get the desirable number of factors. Once again, let me go to analyze.
Sir, one query.
Yes, please, sir.
Sir, in case of cross-loading, we should consider the higher positive value, or can we consider the negative value also? Or the
Sir, we generally consider the higher positive value. It's for our convenience, because all the statisticians and these social scientists are very, very intelligent. They know that they have to consider the positive one. They don't consider the negative one, unless and otherwise maintained in the objective session.
Yeah.
So, dimension reduction, factor analysis. So, all these things are there. Now, extraction. Now, how can we determine the number of factors? How can you determine the number of factors? Go to extraction. Click on the button extraction. Scree plot is there. Now come to the extract part. By default, it is showing that the number of factors that must be greater than eigenvalue 1. You click on this particular factor. That means we are not considering that eigenvalue should always be more than 1. We can determine the number of factors, fixed number of factors or factors to extract. Say we are going to extract 3 factors. I repeat the whole process. Click on extract. We are going to find out the desirable number of factors as per our own necessity or as per our own objective. So this is by default. Then that the eigenvalue must be greater than 1. But we are not considering the eigenvalue greater than 1. We are just clicking on the fixed number of factors to extract. Please try to recall that we had 2 factors in the last calculation. Instead of 2, we are prescribing that we should have 3 factors out there. Fair enough. Continue. Everything else is fine. Now, click on the OK. Let me show you. Let me show you. Click on OK. Let me show you. So again, correlation matrix, something is this, the same value, 0.631, KMO, and all these things are there. Commonalities. Now look at the commonality. The commonality values have been changed. Please try to remember that BMW in the earlier calculation, the BMW value was 0.396 or something like that. Let me show you. This is the earlier commonality. This is the earlier commonality. 0.766, 0.396. So previously, we can remember these 2 values. Mark was 0.766 and BMW was 0.396. Now, after pressurizing the system to find out the requisite number of factors, the commonalities have been changed. So points in place of 0.766 has been replaced by 0.897 and 0.396 has been replaced by 0.998. Total variance explained. Look at here, ladies and gentlemen. Now 3 factors are there. Now look at the scree plot. So there is nothing called eigenvalue because we have not considered the eigenvalue. So here there is no significance of the scree plot. When we are going to determine the required or requisite number of factors, we should not select the scree plot because scree plot is of no use as of now. When I repeat, when we are going to give the requisite number of factors, then scree plot is of no use. If we are considering eigenvalue to be applicable, then this carries some value. So this is how we can determine the requisite number of factors. Sir, ma'am, I mean, am I able to explain how to find out the requisite number of factors out there? Now, let me show you one more important, let me show you what is the result of this particular, this thing, your rotation and all these things are there. Let me show you by taking the example from another variable, from another data set. Just a minute. Just finding out one more data set. Yeah, this one. So, ladies and gentlemen, this is another data set. When I am going to show you, what is known as rotation. What is known as rotation. So this is another, this thing, your data set. So once again, very complicated variables. So please don't look into the variable. This is another, the real data. The paper has recently been published some 3 or 4 months back. This is a real data. Once again, analyze, then dimension reduction, factor analysis. So except this, because it's a string data, so I should not consider this particular data as usual. Okay. Now, descriptive statistics, coefficient, significance level, determinant. Please try to remember that the determinant value must be greater than 0.00001. Then KMO value and BART list. Please remember that the KMO value should be more than 0.6. Continue. Extraction, scree plot. I am considering the eigenvalue must be more than 1. Then rotation. Now the question is that we do not know whether the system is orthogonal system or the system is oblique system. Look at this. I told you earlier, you cannot find out the example or the notation or the determination of oblique or orthogonal anywhere. Please remember that Varimax, Quantimax, and Equimax, these 3 are orthogonal type of rotation. Direct oblimin and Promax, these 2 are oblique type of rotation. First, let us go for Varimax. So Varimax, Quantimax, and Equimax, these 3 types rotations are known as the orthogonal rotation. Oblimin is an oblique type of rotation. What is orthogonal? When the factors are independent with each other and their covariance is equal to 0. What is oblique? When the factors are not independent, they are correlated with each other and the covariance is not equal to 0. Say for example, just we have to go for it by trial and error method, that which particular rotation is going to give you better result. But let me tell you one thing very categorically. In the social science research or in the management research, most of the systems are the oblique one, not the orthogonal one, because all the independent factors are really correlated with each other. So you better get the better result with oblimin or, for example, oblique result. But yes, we have to do every calculation and which calculation is going to give you the better result. But in general, in practice, most of the social science and management systems are oblique, not orthogonal. Let's say, let us click on Varimax rotation. So, rotated solution. Score. There is no score. Fair enough. Fifth one is the same thing. Suppress small coefficient. It was 0.1. Now, now listen very carefully, please, ladies and gentlemen. When we are going to increase the data set, this absolute value of 0.1 or something like that is going to disturb us very much. More number of tests will be produced. So in practice, what we generally do, we increase the absolute value. There are different opinions of this absolute value increase, but most of the people prefer 0.4. That means absolute value less than 0.4 will not be considered. So any factor loading less than 0.4 will not be considered by SPSS. So you have made, you can also give 0.3, it all depends on you. But by default, it is set 0.1. When the small data set is there, it does not create any problem. When a large data set is there, it's creating the problem. So since a similar data set, because sample size is quite a large one, so that means let me give you 0.4. The practice is either 0.3 or 0.4. One school of thought says that this is 0.3. One school of thought says that this is 0.4. I belong to the particular school of thought who believes that 0.4 is much more better than 0.3. So it will minimize the disturbances due to the generation of so many factors or something like that. So continue. Finally, okay. Now let me show you the output. Let me show you the output. Yeah. Now look at this output. Correlation matrix, good number of correlations are there. 0.500, 0.562, 0.722, 0.615, 0.502, 0.635, 0.641, 0.716. So this data set is a very, very robust data set. Very robust data set. Determinant is 0.01. That good number of a large number of correlations are there. So determinant is 0.001. As you know, that determinant must be greater than 0.0001. Look at this KMO. The earlier was 0.61. This one is 0.861. That means very, very adequate sample is there. So that is very much fit. Yes, yes. Any question? So this particular data set is very much fit for doing the factor analysis. But let's test. The significance is 0.000. That means sufficient number of correlations are there. Now the communality. Look at the communality, same thing. So, but we are not interested. You know the communality, that age is 84.6% and all these things are there. So we are not interested in communality. We know that how many factors are there? Once again, 2 factors are there. So 2 factors are produced. Scree plot. Above 1, 2 factors are there. So 2 factors are produced. Now, this is an orthogonal rotation, varimax rotation. It will give you 2 results. One is component matrix. That means before rotation. Component matrix means before rotation. So we may consider it, but since we have rotated the whole thing, we should not consider the component matrix. The next one is rotated component matrix. So we will consider this particular matrix. Look at this. That how powerful factor 1 is. That factor 1 has accommodated all the other variables and it has given only some 2 variables to factor 2. Let us go back. Let us go back. Let us check. Total variance explained. Look at this. The first factor explains almost 59% of the variance, whereas the second factor explains only 18% variance. So that is the reflection you can find out in the rotated component matrix. This is 59% and this is 18%. So definitely factor 1, since it is more powerful, it has extracted large number, maximum number of variables. Factor 2 has only extracted 2 variables. At this particular juncture, let me give you a very, very important information. For any factor or for any construct, minimum number of variables must be 2. You cannot accommodate only 1 variable under 1 factor. That is not feasible. Factor may not become is equivalent to 1 variable. So the minimum variable requirement, is at least 2. Without 2, we should not consider that particular variable. So in this case, you can find out at least the factor 2 contains 2 variables. So this is very, very important, that you should not consider any factor which contains less than 2 components or less than 2 variables. This is very, very important, ladies and gentlemen. So one is component matrix. We should not consider. One is rotated component matrix. Fine. So let me check once again. The question is that now if with the same data set, we are going to apply oblique rotation, then what will be the result? With the same data set, so this is the orthogonal relationship, one is the oblique relationship. We apply the same, then what will be the result? Let me do the same. We are going to apply the oblique rotation. We are going to apply the oblique rotation. Everything is fine. Analyze. Then dimension reduction factor analysis. Everything is same. Coming to the rotation. Any question, ma'am? Is there any question from your side? Instead of varimax rotation, please click on direct oblique rotation, because direct oblique rotation is the oblique rotation. Continue. Then okay. The others remain same. Let me show you. Let me show you that particular the answer sheet or your so-called output sheet. Look at this. Everything is fine, no problem. Same values are there, 2 factors are there. Then where is the difference? Difference is component matrix remains same. After rotation, in case of orthogonal matrix, we have got only 1 table that is known as the rotated component matrix. But in this case, we have got 2 matrices. One is pattern matrix and one is structure matrix. Which one is applicable and which one is not applicable? We should not consider 2 matrices. We have to consider 1 table only. In the orthogonal case, it was very, very simple. One is component matrix, one is rotated component matrix. But in case of oblique rotation, there are 2 tables after this rotation. One is pattern matrix, one is structure matrix. So the question is that when the factors in this case of your, oblique rotation, when the factors are allowed to correlate, then the loadings and the correlation are always distinct. Please remember that two factors I've shown you, they are correlated. So both the loadings and the correlations are very, very distinct. The first one is pattern matrix. Pattern matrix holds the loading. So pattern matrix is equivalent to the loadings, and structure matrix equivalent to the correlation between the variables and the factor. We used to know earlier the correlation between the variable and the factor is known as the loading, but that is in the case of your orthogonal structure. In case of your oblique structure, the relationship between the variables and the factor is known as both loadings as well as correlation. Sometimes, since they're correlated, the factors are correlated, sometimes the correlations are taking the lead seat and sometimes the factor loadings are taking the spin sheet. But the thing is that in case of this particular essential situation, structure matrix is not applicable because structure matrix is taking into account only the correlation. The factor loadings are getting done by the pattern matrix. So we have to accept the pattern matrix itself. So the difference between, that is the difference between your so-called, your orthogonal and as well as your oblique rotation. So the question is that, once again, the complicated term is whether we are going to accept once again the pattern matrix or the structure matrix. For I told you earlier, for the orthogonal factors, pattern matrix is equal to structure matrix. But in case of your oblique rotation, the pattern matrix is used to interpret the factors because pattern matrix is equivalent to factor loadings, and structure matrix is equivalent to the correlation coefficients. So we should not consider structure matrix, we should consider only the pattern matrix in case of oblique rotation. So that's all from my side. Let me take out the data set which I shared with you. And may I request you, to kindly, as is possible, to take out your own data sets which I shared with you earlier. Kindly take out your data sets which I shared with you earlier. Then it will be easier for you to understand. May I request you to take out your data sets which I shared with you. It will be easier for you to understand. It will be easier for you to practice as well. Like for example, this particular data set I shared with you as far as my knowledge goes. May I request all of you to kindly take out your own data set. This is the data set which I shared with you. There are 15 variables, quite a large data set. So please click on analyze. Please click on analyze. Then, at least if this is not possible right now, then go for dimension reduction, then factor analysis. In this particular data set, there is no string variable. So you have to accept everything and just go for variables. Then descriptive statistics, initial solution was there, then go for coefficients, significant levels, then the determinant, because determinant is very, very important, then the KMO and Bartlett's test of sphericity, and continue. Then the extraction process. In extraction, scree plot must be there. If you want to make it, if you do not have any problem, number of factors, then keep eigenvalue 1. If you have a problem with, you have the requisite number of factors, then just click on this particular button and determine the number of factors out there. For our regular calculation, we should consider the eigenvalue as 1. Then continue. Then third one is rotation. You can go for Varimax. We can just calculate. Say for example, for the regular usage, let us consider, though this is not an orthogonal at all, but say for example, Varimax rotation, you can click it. Then continue. Score, no problem. Options. Final one is, say for example, 4.4. Just continue and click the OK. Let me show you the final result. So it will definitely help you out to find out your own result, and you can practice at your home. This is the result. Such a large. This particular data set does not have any multicollinearity, but a number of good quality correlations are there. Let us look at the determinant value. Determinant value is 0.05, definitely much more than 0.00001. KMO value is much higher than 0.6, and Bartlett's test of sphericity, since adequate number of correlations are there, the value is 0.000, highly significant in nature. Commonality. Item 6, item 7, can you look into it? Item 6 and item 7, these two are disturbing variables in our data set. We can remove item 6 and item 7 because in case of item 6, only 45% variance is explained by the factor, and in case of item 7, only 39% variance is explained by the factor. Then how many factors are generated? 4 factors are generated. See, the first factor can explain 23% of the variance of the data set. Second factor can explain 14%, 15% of the variance of the data set. Third factor almost 14%, and fourth factor 10%. That means 4 factors are not in terms of like the previous one. First one could explain 66%, second one 13%, not that. More or less equivalent weightages are there. So ideally 15 factors can be generated, but 4 factors can eventually explain 62% of the total variance. So 4 factors काफी है. Let us go to the scree plot. Above eigenvalue 1, 4 hinges are there. 1, 2, 3, 4. So collectively 4 factors are there. Now let us go to the component matrix. 4 factors are there. Like minus is there or something like that. So we do not want a minus. So you can go for the positive one. Rotated component matrix. Look at this. Factor 1, 1, 2, 3, 4, 5, 6 variables are there. Factor 2, 4 variables are there. Factor 3, 3 variables are there. Factor 4, 2 variables are there. This is also a particular data set where the real data set where the paper is published already. So it's my sincere request to all of you, please practice, because factor analysis is a particular type of factor, is a particular type of analysis which requires a lot of practices. Let me go back to the data set. Let me predetermine the number of factors out there. So this is the final data. Let me predetermine. Everything is fine. Analyze.
Sir, one doubt, sir.
Yes, please.
Sir, one doubt. Sir,
yes,
once
please.
Sir, in the component matrix, once the variables are allocated to the different factors, how we can generate the factor value?
Factor value. It cannot generate the factor. There is nothing called a factor value. The question is that finally, when you are going to utilize this particular variable, the components within this particular factor will act as a factor value. So there is a separate session is necessary to discuss how can the factor analysis results can be converted into multiple regression. Are you getting my point, sir? So there is a separate session required. I have to discuss for another maybe 40 minutes, 45 minutes or 1 hour that how the factors can be utilized in multiple regression as the variables. So with this particular, limited time, it is not possible to discuss because of the limited time, I cannot discuss one more thing, that convergent validity can be determined by factor analysis. If some idea about, say, for example, Microsoft Excel and this your factor analysis, then definitely we can find out the convergent validity by using the factor analysis. And we can also use this particular factors as the variables while determining the multiple regression analysis. But I'm so sorry, sir, because at this particular moment it's not possible to discuss for me because of the paucity of time. Factor, then only one thing is there, go to extraction. Suppose we want 5 factors, say we want 6 factors. Continue. So definitely we do not require the scree plot. So we can definitely go and unselect the scree plot. Okay, let me show you the result. Let me show you the final result. Let me show you the final result. This is the final result. Everything is same. We have prescription is given. Look at this. The commonalities have been changed. I told you earlier, item 7 and item 8 were the disturbing items, right? Now see, it is 0.877, 0.673. Fantastic commonality. Now 6 factors are there. 6 factors putting together have made it 73%. 73% discussion or determination of the variance of the whole data set. So component matrix, 6 data sets. But is it really possible? Look at this. Before rotation, I told you earlier, you should not consider any factor with a single variable. Before the rotation, factor 6, look at this, only one variable is there. The variable value factor loading is 0.565. But after rotation, after the orthogonal rotation, it has become 2 variables. So perfect, no problem. So if you require 6 factors, but the system is giving you by default 4 factors, then you can change it. No problem. The system will allow you. And after rotation, everything is allowed. So that is all about my discussion about factor analysis or exploratory factor analysis, mainly because of how to determine the factors and whether predetermination of factor is possible or post-determination of factor is possible. All these things are there. Now, thank you very much. Any question or any clarification?
Thank you so much,
sir. That is all about my discussion.
It was wonderful. It is such a difficult topic, factor analysis, and you made it so simple.
Thank you so much, sir.
By explanation on the theory part and also on the SPSS side. And it's actually a very, very difficult subject, and you made it really, really simple.
Thanks
so,
a lot, sir.
Very insightful. The comments are coming in now. So, I think floor is open for questions. So, you can ask any questions, Professor Sanyal. Please go ahead.
Thank you, Neham. Yes, yes.
Can we transport the factor analysis to AMOS?
Yes, definitely, sir. Because factor analysis is a generation of factors. AMOS is a particular software, and we can do this structural equation modeling. You know that structural equation modeling is basically a combination between confirmatory factor analysis and path analysis. So structural equation modeling is basically confirmatory factor analysis plus your path analysis. So confirmatory factor analysis cannot be done by SPSS. If you want to make it confirmatory factor analysis, then AMOS software is required for you. So first you have to generate the factors, then just transfer the factors into AMOS. AMOS will give you the requisite result. Any more question, please?
Sir,
yes, please, ma'am. Please.
In the car and cities example, we had derived some factors, 1 or 2 factors. So what could be the meaning of this? I mean, we know that they are unobservable. But is there any way we can give some economic meaning to these factors?
Oh, definitely so, ma'am. Definitely so. Because the naming of the factor is not determined by SPSS. Naming of the factor is to be determined by you, madam, as a researcher. As per your convenience, as per your data set, as per your objective, you should give the name of the factors. This is absolutely independent. You are orthogonal, ma'am. Absolutely independent. You can give the factor name as per your choice and as per your objective. Okay, this is not predetermined by SPSS. We have every liberty, every independence to give the nomenclature of each and every factor. Likewise, for example, let me show you once again, ma'am. Since this a question arises, let me show you. Is that I have shown you earlier that this particular picture, let me show you where it is. Yeah, or no, it is here. Yeah, like for example, I have given the nomenclature of this particular factor as purchase intention. So this is not suggested by SPSS, or this is not prescribed by SPSS. This is determined by me only, as per my own requirement.
Okay, sir. Sir.
Okay, thank you very much. I mean, Dr. Purna, I don't know, maybe, I mean, that is to be decided by Mohanty sir is there. I mean, they will decide, but thank you very much for your kind comment. Yeah, anything else or any other question or any other clarification?
Sir, can you explain the significance of the KMO matrix, please?
Yeah, definitely. The KMO or Kaiser-Meyer-Olkin matrix is the determining factor of calculating the sampling adequacy. If you go through the book of multivariate data analysis by Hare, Black, Anderson, Tatham, and Babin, they have given a chart, madam. What type of chart? Let me show you the chart about the KMO matrix. Let me show you the chart. I believe the chart is available right now with me. Yeah, this is the chart.
Yes.
This is the chart. If the value is less than 0.5, this is not acceptable. If the value is 0.5 to 0.59, this is miserable. If the value is 0.6 to 0.69, this is mediocre. 0.7 to 0.79, middling. 0.8 to 0.89, meritorious. And 0.9 to 1 is outstanding. So this chart is given by here et al. Here, Tatham, Babin, Anderson, and Black. That particular book is there, our holy Bible for multivariate data analysis. You can find out this particular chart is given in that book. Okay, so the basic objective is to analyze whether your data set is sufficient enough or robust, that sufficient number of samples are there in terms of doing the business of factor analysis. Whether factor analysis is possible with your data set with a sample size will be provided by or will be determined by the KMO value. Yes, anything else?
Yes, sir. Okay.
Sir,
Yes,
excuse me,
please.
sir. Yeah, so
Yes,
can you
ma'am.
just tell me how to find the validity of the variable? Like we
Yes,
used to
ma'am.
find.
Thank you very much. That's why I was telling, yeah. One gentleman asked me the question that while I was discussing about the convergent validity. There are different types of validity. So convergent validity, discriminant validity. Convergent validity can be determined by this factor, this SPSS or factor analysis with the help of Microsoft Excel. That can be possible. But since due to the paucity of time is not possible right now for determining that particular. But yes, convergent validity can be determined by factor analysis with the help of Microsoft Excel.
Okay. Thank you, sir. Thank you.
That is possible. That is feasible as well.
Yeah.
Anything else? But my sincere request to all of you, ladies and gentlemen, available data is there with you, and there is quite a robust data. This is the data from one of my own research works. Please practice at your convenience, because factor analysis is quite a complicated, as rightly pointed out by Mohanty sir, is quite a complicated one. The more you practice, the more it will be absolutely, explainable to you. You can handle it with more ease. So it's my sincere request to all of you. Any more question from your side, ladies and gentlemen?
So one last question. Please explain the significance of the determinant that you talked of in the output. The determinant.
Very good. Absolutely. Very good question. The determinant value should always be greater than 0.00001. That means 40, then 1. If the value is greater than 0.0001, which indicates that enough correlation has been established in the whole system, and the whole system is robust enough for the further communality. So communality can be extracted to the fullest extent if the determinant value is, and the correlation is perfect over there. Because please remember that the determinant value has a direct relationship with the Bartlett's test of sphericity. If determinant is more than 0.00001, then the significance level of Bartlett tests of sphericity must be significant. If the determinant is less than that, then the value of Bartlett's test of sphericity is expected to be non-significant. Anything else? Anything else, please?
Excuse me, sir. Regarding the first data you showed regarding the car, the different types of car, how we write the conclusion or the description at the end based on this factor analysis?
Very good question.
How we say the message?
Very good. The question is that there are two factors. As far as my knowledge goes, there are two factors. So you can name the two factors. So the 6 variables are there, and the 6 variables are cars are there. So two factors. These two factors can accommodate 6 cars out there, 6 variables out there. So you can give the factor name as, say for example, say car choice 1 or car choice 2, something like that. Just a discussion part there. Car choice 1, car choice 2. Then you can finally write down that out of the 6 variables over there, we can finally find out 2 different factors. One is car choice 1 and one is car choice 2. And car choice 1 accommodates, say, A, B, C, these 3 cars. And car choice 2 can accommodate, say, X, Y, Z, these 3 different cars out there. That means factor 1 or car choice 1 can accommodate 3 different types of car, and car choice 2 can accommodate 3 different types of car. And there is no relationship between car choice 1 and car choice 2. That means the customers who have chosen this card choice 1, they will not choose the card choice 2. Or the customers who have chosen, say, ABC, these 3 brands, they will not choose XYZ, these 3 brands. Or conversely, customers who have chosen card choice 2, that means XYZ, these 3 different cards, they will not choose card choice 1 or ABC. Got the point, sir? This is how to explain each and every factor.
Could you please explain about the variance? What specifically means the variance?
The variance means the same thing is variance. Whatever the variance is applicable in case of your normal statistical tools. The question is that when there is we know that when there is a variability within a particular data set, that is known as a variance. So in terms of the factor, that variance must be always to the higher node, because there's a question like that you can easily observe this covariance matrix or correlation matrix. You know that, sir, there is always a difference between covariance matrix and correlation matrix, and covariance matrix is much more applicable or acceptable than the correlation matrix, because correlation matrix, some other problems are there because covariance matrix. But in practice, we do not always get the idea, or do not always get the, the feasibility of using the covariance matrix. So you have to use the correlation matrix. So the question is that covariance is always needed if you compare within a particular data set, within 2 different data sets. But variance is expected within a particular, suppose for example, that you have only one particular data or one particular variable. Within that particular variable, different data are there. So there must be a variance within the data. So if the variance is not acceptable, then how can we expect the covariance will be applicable? Because the covariance is between the variable and the factor. So if the variance is not acceptable within the particular data, we cannot expect that covariance will be very much applicable. So there could be a problem in terms of the factor loading between the variable and the factor out there. This is the significance of technical variance.
Thank you, sir.
Anything else? Anything else? Anything else, please, ladies and gentlemen? So if not, then in the end, thank you so much, and my sincere namaskar to all of you. Thank you very much. Please stay safe, please stay home, and take care of yourselves. Mohanty sir,
thank you so much, sir. In fact, as you would have seen, there's a comment about another session on MOS and structured equation modeling. So we will work out with the participants about maybe one single session from your side, because as you have rightly pointed out, one session is too small for this complex topic, though you have done quite a lot of justice to it. And there's a lot of excitement about it. And it's true that today's research usually are ending up in factor analysis, and people get totally bogged down with the numbers and reducing the factors towards the end. And sometimes they forget about what is the objective of the research, because they're only talking about factor analysis towards the end.
Exactly.
So, when we were discussing the curriculum of this workshop, Dr. Sanyal actually said that there has to be a session on factor analysis, because usually this thing is not there in most of the FDPs. And as it is there, it was very well presented by Dr. Sanyal. And sir, thank you so much. And we'll come back to you again on one more session with you as per the demand.
Thank you so much, sir.
As per the convenience of Dr. Sanyal. And thanks again so much, sir. And any question, any last question to him?
Last question.
Feel free to ask.
Absolutely. Anyone, please, sir, ma'am, anyone. And thank you.
Sir, I'd like to ask a question.
Yes, madam, please go ahead.
Sir.
Please,
Sir, please, I'd like to ask a question. First of all, though, thank you very much for bringing to light such a wonderful topic. And you have talked about the Likert scale items that a more robust kind of a Likert scale, like having 9 items and 11 items, would be more effective in going through factor analysis. So could you just throw light on that, sir?
Ma'am, the first question is, I have not told that 9-point or 11-point Likert scales are applicable for factor analysis. Factor analysis can be
you have
done.
Not told that. Yes, sir.
I have told that in order to attain the normality of the particular data set, you may increase the points of that. Maybe I do not know, because there is no scientific proof in favor of my statement. But I believe that, and I have not tested by myself, I believe that if you increase the Likert scale by 13 or 15 points, then we can achieve the normality. But the thing is that if you increase your Likert scale by 13 or 15 point, it will be very, very difficult scale, madam. Very difficult scale. It will be very difficult, rather impossible for a respondent to give the response for a 13 point or 15 point Likert scale. Very, very difficult. So we have to satisfy ourselves with a 5 point or 7 point or maximum 9 point Likert scales. The question is that in case of factor analysis, multivariate normality is not required. In case of confirmatory factor analysis, because we are using maximum likelihood estimation technique, that estimation technique is so robust, so powerful that it does not bother the multivariate normality, I mean the particular data set. So this is something that is very important. Likert scale, even 5 point Likert scale, we can perform our factor analysis.
Thank you, sir. Thank you, sir. Thank you, sir.
Thank you. Thank you so much to all of you for your kind participation. Thank you so much, Mohanty sir. Thank you very much, Akshita.
So and of course, and I just have a very small announcement here. In fact, tomorrow's resource person, Dr. Ashutosh Mudli, is here, and his topic tomorrow is interpreting SPSS results and their implications. So he wants basically 2 volunteers for tomorrow's presentation, and he'll explain what exactly he wants to do tomorrow, so that people get more insights out of his presentation tomorrow. Dr. Ashutosh, please spell out your requirements. Is there? Yeah, he's there.
Hello.
Yes, sir. You are audible. You can speak now.
Am I audible?
Yes, you're audible, sir.
Okay.
Yes, sir.
Yeah. Thanks, thanks, Dr. Sanyal. I think it was a wonderful session.
Thank you so much, Dr. Mudli.
I think,
My pleasure.
like, yeah, extending the research methodology workshop, especially, towards factor analysis, really quite unique and unprecedented. I've seen that most of the research methodology workshop, they tend to talk about only t-test, then correlation, regressions, and then finally they concludes. But I think that's the uniqueness of Dr. Datta's academy and the able mentoring of Mr. Mohanty. Absolutely. And of course resource.
Absolutely.
Resource. Yes. Okay. So participants, I know, like, you all are getting a lot of, you are getting late because you are stretching since 6 p.m. This is regarding my, tomorrow's session. You all know that in tomorrow's session, we will be talking about how to finally use this data. Remember, whatever you have done so far, whatever, you have learned so far, these are nothing but the inputs. Okay. These are only mere inputs. Don't forget this. You are not a statistics expert. You are not supposed to be a statistics expert. If you hold the position of a research scholar, or if you are a faculty somewhere, but then want to strengthen your research grip, okay, don't forget that for you, research methodology, especially statistics, is just a tool. Okay. And most of the things depends on how you are going to use this data when it comes to findings, when it comes to implications and discussions. So unless you know the trick of, oh my God, yeah. So yeah, so unless you know the tricks of interpreting it in a way which is acceptable to the larger world, larger academic and research world, I think all your hard work may go waste. Okay. So it is in that context we have tomorrow's session. I am not going to take a session, of course, today. I'm very clear about it. But then please read a material which must have said by Mr. Mohanty that talks about a high performance work system. It's a research article, my own article. Next day, tomorrow's session we'll try to understand the implications part using this particular research article. But then the point which is quite important for all of you, which is that like I want to volunteers, especially researchers or like faculty colleagues who have already analyzed the data and the model is very clear to them, and their analysis is almost completed, because I want a real life example, a live example, which has to be demonstrated by some of the participants, because I can explain and I will tell you the tricks, I will tell you the methods, but then don't forget the objective of this research methodology is also to give you an experience of work and experience. So work and is possible only when you will work on your data. Okay, so at least 2 volunteers I need who should share with me or like who should be ready to interact with me tomorrow morning at any time. And I would request Mr. Mohanty to share my numbers with them, so that I can be in a position to talk with them and I can mentor them, I can guide them, so that they'll prepare at least 3-4 slides, which is to be shared as a part of that session also. Okay, so my plan is I may speak for 1 hour, and the remaining 1 hour, 1 hour will be spoken by the participant, especially these 2 mature scholars who will be presenting their slides, and there a lot of discussion may happen. Is that clear to all of you?
So this will be like a case study.
Exactly.
Two participants, yeah. And maybe after their presentation, you can award the PhD degree to them.
That's true. That's true. I mean, I may not able to award a degree because I am not a competent authority to award a degree. I am sure Dr. Sanyal agrees with me. But then, but then it can give them a feeling that yes, now they are resourceful to write discussion implications and various critical things of a research, right? Right? Is that
right
clear?
Now almost 50% of the participants are there. If anybody can volunteer right now, they can do it right away. And I share Dr. Mudli's number on the WhatsApp group, and you can independently interact with him in the morning session.
Yes, I'm ready to do that. I can spare time for you, of course. See, it requires a lot of handholding. Okay, without handholding, it is not possible. But I cannot do handholding for all 60 participants. On first come first basis, we can entertain 2 participants. Okay, but provided the participant should have analyzed the data, considering the tips and guidance given by all our esteemed speakers since last 4 days, and the model must be clear to the participant. Once the model is clear and the result is available, then we'll do handholding and we'll try to see what can be done.
Yeah, I think this is taking it even one step further, because we never wanted PPT kind of presentations. So we had a combination of theory and hands-on workshop, and this is actually a real case analysis of participants with experts.
Yeah.
So this is really, very, very enriching.
That is the biggest challenge always with the researcher. I think my colleagues who are into writings, who are into the advanced stage of their PhD, or who have submitted research paper to international journals, I am sure like most of the time their paper gets rejected because of this particular inability. So having numbers only won't help. You should try to tell what those numbers talks about, and how it is going to be useful to the larger academic world or to the larger business world. Unless you know these tricks, it will just end up with few numbers, and So any volunteers so far? Anyway, don't you must be scared, because I know tomorrow you have your classes in the university, and फिर कब आएंगे, कब presentation बनाएंगे, कब क्या करेंगे? It's very tough. But take your own time. My number, Mr. Mohanty will share with you, of course. And if you find comfortable, if you are confident, okay. I don't want 100% confident. 100% confidence होता तो आप थोड़ी यहाँ सीखने के लिए आते हैं. Okay, but then you have 100% confidence on you that yes, you can learn and you can demonstrate, you can present. Okay, ये जो self efficacy अगर है, so just give me a call or write on my WhatsApp. That is my WhatsApp number, in fact. write on my WhatsApp, and we'll see what can be done. Fine.
Yeah,
That's all from my side.
And that will be very useful for the participants who actually volunteer.
Yeah. That's all from my side. So thank you, Mohanty sir, and thank you, Dr. Sanyal. I mean, factor analysis is really factor analysis is such a topic which never ends. Like I still recall, like
it's a never-ending one. Yeah,
it's a never-ending topic. I think therefore, like hats off to you. Like within 2 hours, you could able to summarize all the components of factor analysis, which is really quite challenging. I know.
So in case there is any last minute question, then we can just wind up and I'll share your numbers, Dr. Mudli, in the group. And so any questions? Any volunteers?
Any volunteers? No problem. I mean, you might take your time. No problem.
All right. So we'll wind up for today. Right. Thank you all so much. And we'll see you tomorrow for the last session of the FDP at 6 o'clock tomorrow. 6 p.m. in the evening tomorrow.
Yeah.
Thank you so much. And I'm just ending the meeting.
Yeah. Thank you, sir. Thank you.